Hello everyone, I welcome you all in this C programming and data structures lecture. This is part 2 of Stack's linked list implementation. Actually, this lecture is in the continuation to the previous lecture. This means we are continuing with our discussion on linked list implementation of stacks. So without any further delay, let's get started. Here is the outline of this presentation. First, we will see the structure of the node, the actual structure of the node, which will represent the element of the stack, right? So we'll see the structure of the node. Then we will see the push function code. And finally, we will see the actual implementation in the IDE. Okay? So these are the things which we will discuss in this lecture. First, we will see the structure of the node. How to create a node of the linked list? It is very simple, right? Structure of the node representing a stack element is same as the structure of the node of the singly linked list, right? We know that we are representing a stack with the help of a singly linked list. So structure of the node of the stack must be same as the structure of the node of the singly linked list. So here I have declared a struct node, and you can see inside the struct node we have int data and struct node star link. It is same as the structure of the node of the singly linked list, right? But what about the top variable? How to declare a top variable? In this case, we don't need a top variable. We need top pointer instead, right? There must be some pointer which points to the first node of the linked list. There is no requirement of creating a top variable. Top variable is required in case of arrays, not in case of linked list. We need a pointer that must point to the first node of the linked list, right? We will replace the top variable by a pointer named top. Okay. This pointer must always point to the first node of the linked list. But how to declare the top pointer globally in the code? We can declare a top pointer globally. There is no problem. For this, we will mention something like this. Star top equal to null. Obviously, this top pointer must point to the first node of the linked list. This means the type must be struct node. That is why I have written star top equal to null over here. This piece of code will be declared at the top in the program and it must be global. Therefore, automatically this top pointer will be global. And here you can see I have initialized it to null. This is also important. Currently, the stack is empty, right? That's why the top must be null. So we are done with structure of the node. Now we will see the push function code. Push function of a stack is similar to the add beg function of the singly linked list. It is similar to the add beg function. If you have seen the previous lectures, then you might be aware about this, that how to add a new node at the beginning of the singly linked list. And there we have seen a function named add beg. Okay. Push function of stack is similar to the add beg function of the singly linked list with small changes. We'll make some changes to this add beg function. Obviously, it is not going to be the same thing, right? So in the push function, there will be some small changes. This is how our add beg function looks like. I took this from singly linked list lecture. Okay, this is add beg function, and this function is capable enough to add a new node at the beginning of the linked list. Now, we will create a push function which will act similar to this add beg function, but there will be some minute changes. Below is the initial state of the linked list. This is how our linked list looks like initially. I am assuming that this is the initial state of the linked list. And you can see that top pointer is currently pointing to the first node of this linked list. This means this is the topmost element of the stack and this is the second topmost element of the stack, right? Let's say we are interested in pushing the element 50 onto stack. Let's say we are interested in pushing this element onto stack. How do we push this? For this, we have to add a new node with the value of 50 in its data part at the beginning of the above list. So here, obviously, we need to add a new node with the value of 50 in its data part at the beginning of the above list. The procedure is simple. First, we have to create a new node. Then we have to put the address of the first node, that is this node, in the link part of the new node. That is what I have written over here. Put the address of the first node of the above linked list in the link part of the new node. Okay. First we have to create the new node. Then we have to update the link part of that node so that it can point to this node, right? update the top pointer after that and make it point to the new node of the linked list. Then you have to update this top pointer so that it can point to that node, right? This is the simple procedure which we have to follow. So let's see the first step of this procedure, that is create a new node. How to create a new node? It is very simple. We need to call a malloc function, right? Here first I have declared a new node pointer. Then after this, I'm using malloc function to allocate memory for this new node. And this is how it looks like. Okay. So memory is allocated and new node is currently pointing to this particular memory. Now, it is important to update the data part of this node, right? Let us suppose that data is 50. We want to add this new node in front of the linked list and data must be 50. So here I'm assigning this data, that is 50, to new node data, which means I'll simply put 50 over here. After this, it is important to update the link part of this node. Currently it must be null, right? So here we'll put null. I'm representing null with this shaded region. Okay. Next step is to put the address of the first node of the above linked list in the link part of the new node. Above linked list means this linked list. Okay. Currently you can see the top pointer is pointing to this node and this is the initial state of the linked list. We have to put the address of the first node of this particular linked list in the link part of the new node. Okay. How to put the address of the first node of this linked list in the link part of this node? It is simple. You just have to put this line of code. New node link equals to top. With the help of top pointer, we can get the address of the first node of this list and we can put that address inside new node link. That is, we will update the link part of this node by the address of this node. And after this is how it looks like, right? Now this node is pointing to this node. After this, the last step is to update the top pointer and make it point to the new node of the linked list. Now it is important to update the top pointer so that it can point to this node because this is now the topmost element of the stack, right? That is why it is important to update the top pointer. So here we can update it with the help of this line of code, top equals to new node, right? So here we will update the top pointer and this is the final result so obtained. This is the initial state of the linked list and this is the state of the linked list after insertion. Here is the complete function, push function. You can see this push function is receiving data and here I have declared a new node pointer and here we have a malloc function which will allocate memory and it will return the address of the node and we will then store that address within this new node pointer. After this, I am checking this condition. If new node is equal to null, then print stack overflow and exit with exit failure status. We are already aware about this, that malloc function returns null when the requested memory can't be allocated. It might be possible that the heap memory is not available. Then in that case, malloc returns null. Obviously, if malloc returns null, then it will get stored inside this new node pointer. Then we can check, is new node equal to null? If at all it is the case that new node is equal to null, then this message will get printed on the screen, that is stack overflow. Okay, and then in that case we must exit from the program with exit failure status. This is an abnormal termination, right? Here we are checking if malloc returns null, then this means stack is full. And obviously after this we are aware about this piece of code. We will not return anything from this push function. That's why the return type is void. So we are done with the push function code as well. Now it's time for the actual implementation in the IDE. So let's move on. This is the complete code. You can see two libraries are included. Struct node is declared. This is the top pointer. This is a global pointer which is initialized with null. We have this push function code and then we have this print function code to print all the elements of the linked list, right? Here I have declared a temp pointer and I have assigned top to temp, which means that I am simply assigning the address of the first node to temp. Then I'm calling the printf function to print this message. The stack elements are. Then after this, with the help of this while loop, I'm trying to print all the elements of the linked list, right? While temp, this means while temp is not equal to null, print temp data and update the temp by temp link. You're already aware about such type of code, right? And then after this, we'll simply print \n for new line. Here we have this main function and I have created a simple prompt over here. While 1 means while true. This means that this loop will run infinitely. Now here I'm trying to print 3 different messages. 1 for push, 2 for print, 3 for quit. Now here I'm asking the user to enter your choice. User will enter his or her choice and we will store that choice within this choice variable. Then in the switch case, I'm passing choice, and if choice is 1, then it is important to ask the user to enter the element to be pushed, right? User will enter the element and then we will push that element inside stack. If choice is 2, then simply the user wants to print all the elements of the linked list. So we have to call the print function. And if choice is 3, then exit with exit failure status, right? Otherwise, if it is a default case, this means if the choice is other than these 3 choices, then print wrong choice. Okay, so let's execute this code. 1 for push, 2 for print, 3 for quit. Let's say I want to push an element onto stack. Let's say I want to push 67. It's done. Now let's push one more element. Let's say 90. Okay, fine. Let me print all the elements on the screen. This is how our stack looks like, right? These are all the elements of the stack, 90 and 67. 90 is the topmost element of the stack and 67 is the second topmost element of the stack. Now we can quit. Our code is working fine, right? Okay friends, this is it for now. Thank you for watching this presentation.